Welcome. In this video, we're going to explore the power of regular expressions, or regex, in the command line. We'll be focusing on tools that will help you master pattern matching directly in your terminal. Regular expressions are sequences of characters that define a search pattern. Think of them as a supercharged find and replace for your terminal. We will cover grep, sed, and awk. Each of these tools serves a unique purpose when it comes to working with text and patterns. First up, let's dive into grep, short for Global Regular Expression Print. Grep is your go-to tool for searching and filtering text. It searches through files or input for lines that match a specified pattern. Here is the basic syntax. You type grep, followed by any options you want to use, then the pattern you are searching for, and finally the file you want to search within. For example, grep error logfile.txt searches for the word error in logfile.txt. Let's explore some common options. The I flag makes the search case-insensitive, meaning it will match both uppercase and lowercase letters. V inverts the match, showing you lines that do not contain the specified pattern. N displays line numbers along with the matched lines. R allows for recursive searching through directories. Finally, E enables extended regular expressions, giving you more powerful pattern matching capabilities. Let's look at some grep examples to understand it practically. First, for a basic pattern search, the command grep error logfile.txt searches for all lines containing error in the file logfile.txt. Similarly, grep iWarningSystem.log searches for lines containing warning in system.log, ignoring the case. In the second example, for using regular expressions, the command grep is 0 to 913 / 0 to 913 file.txt searches for patterns that look like numbers, specifically sequences like an IP address, in the file.txt. The command grep error application.log searches for lines that start with error in application.log. Now let's explore sed, which stands for Stream Editor. Sed is a powerful tool for performing text transformations. It allows you to substitute text, delete lines, print lines, and perform global replacements. Here is the basic syntax. Sed, then in single quotes s/pattern/replacement/ then the file name. For example, sed s/old/new/file.txt replaces the first occurrence of old with new in file.txt. Here are some common commands. S is for substitute, replacing a pattern with a replacement. D is for delete lines that match a pattern. P is used to print lines, often used with options to print specific lines. G performs a global replacement, replacing all occurrences of a pattern in a line. The I option allows you to edit the file in place, saving the changes directly to the file. Let's consider a couple of sed examples. For text substitution, sed s/old/new/g file.txt replaces all occurrences of old with new globally in file.txt. The command sed s/0 to 9 \xxx/gdata.txt replaces all sequences of one or more digits with xxx in data.txt. For line operations, sed 3d file.txt deletes the third line from file.txt. The command sed /#d conv.txt deletes all lines that start with a hash symbol, which are often comments, from config.txt. Let's move on to awk, which is a versatile pattern scanning and processing language. Awk is designed for more complex data extraction and reporting. It excels at processing structured text like columns in a file. Here is the basic syntax for awk. You type awk, then in single quotes you specify a pattern followed by an action in curly braces, and finally the file to process. For example, awk print $1. File.txt prints the first field of each line in file.txt. Awk also has built-in variables that you can use. $0 represents the entire record or line. $1, $2, and so on represent the individual field values. NR stands for record number. NF stands for the number of fields in a record. FS defines the field separator, which is often a space or tab. Let's explore some awk examples. For field processing, the command awk print $1, $3, data.txt prints the first and third fields from each line in data.txt. The command awk patterm print $2, file.txt searches for lines containing pattern and prints the second field of those lines from file.txt. Let us consider another example for pattern matching in math. The command awk $3 greater than 100 print numbers. TXT prints lines where the third field is greater than 100 from numbers.txt. The command awk sum plus equals $1 nd print sum calculates the sum of the first field in each line and prints the total at the end. Now let's see how to combine these tools for powerful workflows. By piping the output of one tool into another, you can create complex data processing pipelines. Here's an example of a pipeline. Grep error log file.txt said s/********1/awk count $0++ and for I in count, print count II. First, grep extracts the error lines from log file.txt. Then, set cleans the format by extracting relevant information. Finally, awk analyzes and counts the occurrences of each error. These tools are used to create a complete workflow, where grep extracts the error lines, set cleans the format, and awk analyzes and counts the occurrences of each error. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.